Disclaimer, disclaimer, disclaimer. The greatest moments in scientific history occurred first in the mind of a child. It is in the moment of recognition, a thrilling excitement of the mind while viewing something you know to be truly new. A hypothesis followed that works itself out on paper and again in a lab or even in the stars. An observation that unlocks the inner workings of a world whose locks have been picked at for generations. It is our never-ending novelty of newness, the exhilaration of discovery that keeps the human mind searching for more knowledge. It is a natural curiosity of the human spirit that we are born with. As infants, immersed in a continual state of fearless exploration, of constant discovery and expanding recognition, so much information is acquired seemingly effortlessly in such a short period of time, and again and again and again as we race towards adulthood, that it is impossible to separate our humanity from the pursuit of knowledge. The nature of our vitality is so rooted in our infant curiosity that without it, if we lose the desire to learn more, we fail to measure up to the courage of a child. And brave children we are all here on This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kirsten.
Good science to you too, Justin. Another week and lots more science in the lineup. It's just awesome. Just awesome, the amount
March
of science.
1st already.
I know. And there was even a leap. It would have been March 2nd if there hadn't been a leap day in there this last week. They stuck this extra day in the week, and then there you go, right?
Awesome. Yeah,
leap?
another jam-packed week of sciencey goodness out there. I've got some interesting stories here. I've got Neander pirates. I've got new and improved marijuana. You thought the stuff that was out there now was good. Wait till you hear this. And this is and a hunt for ancient Ohioans.
Ancient Ohioans.
Did you even know that there were ancient Ohioans?
Nope, can't say that I did. But now
they're
I'm
being hunted.
Intrigued. Hunt them, find them, bring them to me. Oh my goodness. What do I have? I've got stories about, what do I have? Missing antimatter. I've got an Itokawa update and some world robot domination. Yeah, and we have an interview today. An interview with science writer Carl Zimmer. He's written a book that Twis has been reading as our book of the month, A Planet of Viruses. And so we're going to talk with him about viruses and other fun things. Yeah, it'll be awesome. So that's coming up in the second half of the show. I hope everybody's looking forward to that. And in the meantime, let's jump into the science because we don't have a lot of time to get to all the stuff that we brought. Yikes. Just want to do a real quick update about the ongoing open science battle, publishers versus open science, and the Research Works Act bill that was put before Congress to stop federal agencies from requiring that their grantees, people who get grant money from them, actually put their research, that's been written up in open access databases so that members of the public can access it. Also, that would lead to publishers of scientific research, the journal publishers, not having to make the stuff that they publish freely available to the public, which currently, if you get U.S. government funding, publishers have to make your research available within 6 months of having published it. But the Research Works Act bill would have gone against this. Now, Elsevier is a giant powerhouse in the publishing community, and this last week withdrew its support of the Research Works Act. So, in effect, because they are one of the largest publishers out there, they have a bunch of highly rated science journals. They are, I guess, highly esteemed in the publishing world. So, so their voice carries a lot of the weight, and the fact that they've pulled out of this act has left the act kind of dead in the water. And so the representatives Daryl Issa and Carolyn Maloney actually have withdrawn the bill. So the Research Works Act is dead officially, which is a victory for open publishing and open science for the time being. Boycotters who had boycotted Elsevier based on its publishing practices, the anti-open stance that they take, are still calling for a better situation and are still boycotting Elsevier. And jumping forward into some other cool news, antimatter. Where is all the antimatter in our universe?
It's missing. It's all missing. It's supposed to be there, but it's not.
Exactly. Where is it? It's supposed to be there. You're supposed to have matching numbers of particles, right? For every matter particle, there should be an equal number of antimatter particles. But that's not the case. We have an asymmetric universe, a mostly matter universe, very predominantly made up of matter. Everything, my table, this microphone, the screen that I'm looking at right now.
And at least
it's made of matter, not antimatter.
My rudimentary understanding of this is that in the beginning, there were equal amounts of matter and antimatter, and they pretty much canceled each other out. And so what we have is this mattery universe is sort of like the leftovers, like some sort of random amount of, if you just flip the coin and you ended up with a couple more heads than tails, right? Like,
right. So if you have
little
the same
sliver of what's left.
But if you have the same number of matter particles and antimatter particles, and when they come into contact, they annihilate. If you had the same number of particles and when the particles came into contact, they annihilated everything, even in symmetric, there would be no universe in existence. Everything would have evenly canceled out. So somewhere there's an asymmetry. So either there were not even numbers of matter and antimatter particles in the beginning, or there were equal number of particles, but somewhere along the way, something started decaying in an asymmetric way. So matter particles of some form probably decay a little bit slowly or more quickly, and then similar antimatter particles, and maybe create a different situation. And so one of the experiments at the Large Hadron Collider in CERN is looking into trying to find out the basis for this asymmetry, trying to find out where the missing particles are. And so this experiment has the LHCb had actually announced a particular set of results last year in 2011. They reported a difference in between matter and antimatter decays of about 0.8%. And based on theory, it should be less than 0.1%. But it's much larger, 0.8%. And they said, this is weird. So based on our standard model of physics, that suggests that it should be a 0.1% or less difference, we shouldn't have this result. But this is what we get. And so the only way they can verify that is with an independent test of a similar kind. And so the CDF at the Tevatron, which has now been shut down last September. It was shut down. This is at Fermi Lab in Batavia, Illinois. They have done an independent test of this, looking at these D mesons and how they decay into other particles, charm quarks, and kaons and pions. They presented data, their data, very similar to LHCb. Their difference was 0.62%. That, again, much higher than 0.1%. So in the physics world, you have the statistical significance of your result is very important. If you have a 3 sigma result, that means that it's pretty good. It's kind of like 50-50, a little bit better than 50-50. It's not chance, but it's not great. It's a decent result, but it's not that strong. A 6 sigma result.
You wouldn't want to run trains or land and take off airplanes with that.
Yeah, 3 sigma is it's not 50-50, but it's here it it's a 3 sigma is about the same likelihood as tossing more than 8 heads in a row. So significantly more than 50-50. I got that completely wrong. But it's not great in terms of the size of the universe and the number of times you want to see things happening and what you want for your response to be. And what they found with these results, it's about a 4 sigma significance. So it's better than 3 sigma. It's almost 5 sigma even. And so the fact that they've got these that they're finding this level, it's about 1 in 16,000 chance that this is a statistical anomaly at this point. So the question now is, are the calculations wrong? Is the standard model wrong? What's going on? And so researchers, the researchers are saying, one is quoted as saying, this effect is definitely much larger than anything that had been predicted. So there will be discussions between the theoreticians asking, is this really new physics or did we get our calculations wrong?
Right. And the great thing about the standard model, too, is it can actually be wrong because we're still perfecting it. We're still creating the model. We're in the act of making the model now. We have the part that we've completed so far. And then as we learn more, we can make more adjustments. The standard model will continue, but it will be added to over time, for sure.
Yeah. Anyway, it's pretty interesting. Independent confirmation makes it very intriguing. We shall see. More antimatter news to come.
Let's see.
What you got there?
Neanderthals in the news. This is the separate species, much maligned hominoid Neanderthal that lived from at least 300,000 years ago, maybe longer, to as recently as around 24,000 years ago in sort of the Middle East and Europe and France and that sort of area in there. Before we bred them into extinction. At least we know that much. We don't know if we competed them out of existence or if there was a climate thing happening, but we do know that at least we have bred with Neanderthals because they're present in the DNA of pretty much all westernized Homo sapiens who can source origins to the Middle East. So some of the artifacts, these stone tools that they use, and this is one of those things too that people don't realize sometimes when talking about Neanderthals, they had stone tools, they could make fire, they buried their dead with ceremony. They had sort of burnt offerings of herb that they found buried with their dead, along with jewelry and the like. So this is not in any way, sense or form, a primitive man. It's a separate species, of course, but it's also much more advanced than I think people normally picture a Neanderthal to be. So they've been discovering their tools that are uniquely associated with them on islands in the Mediterranean Sea, suggesting, at least according to this one paper published in the Journal of Archaeological Science, written by George Ferentinos and his colleagues, that Neanderthals perhaps had figured out a way to travel the seas like salty Neander pirates of old.
Salt. Arr.
And that must have happened if this is correct, if they are correct in that Neanderthal managed to master the sea, they would have done so perhaps 50,000 years or more before modern man acquired the skill, at least to our, So there is a big complication in this, of course, because finding vessels that somebody may have used for sailing or boats, they would have been very primitive constructions, would be perhaps hard to decipher. First of all, wood doesn't survive very well. We don't find, bone fossilizes, and it's a great process. We have fossilized bones go back millions and millions and millions of years back. We can see dinosaur fossils. Wood is a lot trickier. So if we were using wooden boats, sort of maybe a primitive construct to what we consider a boat today, they've been maybe lashed together logs or something like that. Very hard to find evidence of that. And so far, there is no evidence of Neanderthal sailing vessels. But what they're looking at is the Mousterian tools, or Mousquetaire tools, as I'm going to call them, that are unique to Neanderthals. They're associated with Neanderthal. We know Neanderthal was making this specific type of tool. They've been found on islands of Zakynthos, Lefkada, and Kefalonia, which range from 5 to 12 kilometers from mainland Greece. And some, such as this is Paul Pettit, University of Sheffield, suggest they could have swum that far. But now that doesn't explain this finding of these tools on the island of Crete. They don't understand how these tools, they could have swam there. Because they've looking back, this is some 40 kilometers, which is about, 20 miles? That's a lot. It's a really long swim. And they've also been able to determine that the island of Crete has been the island of Crete. They have never, in this time frame, been able to construct the idea that there was some sort of land bridge or ice bridge that could have been walked to. No, this has been an island. It's been around 20 miles off the coast of Greece.
So they found the tools. They're finding tools and stuff, but they haven't found any boats or anything. They haven't found anything that looks...
Because again, that's something that's going to deteriorate. It's not like what they're finding in terms of stone tools, which are going to last, for...
Especially if the boat was just a raft of pieces of wood that were lashed together we don't somehow.
Know what they... It could have been a finely carved, like... Viking longboat. We have no idea, right? That's a little doubtful, but we still wouldn't know. So even if it was just found a log to float on and decided, hey, that's good enough, I'm taking to the sea. The other part of it is you wouldn't be able to see the island of Crete 20 miles out, right? You wouldn't have vision of it. So it's not even like you could say, I'm going to jump on this floating log and keep kicking my feet till I get to that speck of land over there, because I see it and I know it's there, and I want to go discover what's over there. They wouldn't have even had that landmark out there to necessarily shoot for. So it sort of indicates that maybe they were out there on the seas exploring, maybe, who knows, fishing, who knows, right? But it's just very interesting now that they found these stone tools there. They're believed to date back to about 100,000 years. Our first evidence of humanity, and again, we have the same problem. Our boats deteriorate too, but our first evidence is about 50,000 years ago. So it's quite a distance back further. They've doubled us in having the first boat thus far, perhaps, right? Mm-hmm. So others have suggested that we may have been sailing as long as 1 million years. It gets even more interesting, because then you look at the stone tools found on the island of Flores, right? Homo floresiensis. They found there's tools that date that far back. Now, that's an area where I've heard the proposition that there was the land bridge and ice bridge, and there could have been a walking migration out that far to India, at least. Indonesia, I don't know. That's a little further out. That's so, now we got little people with boats. Everybody's got a boat. These primitive modern humans are still walking everywhere. Very fascinating idea, though.
Yeah, I wonder. There are stories of people who live near the water. Sometimes weather occurrences happen where people get caught up in kelp or in some kind of material that can carry them someplace else. Maybe they're in a storm situation and they end up holding on to a tree trunk and floating 20 miles to the island of Crete or to the island of Flores. So. But then it's only one person. How many people are there? How many, if it's one person, they're going to make their own tools. Are they finding enough tools to indicate that there would be a larger population, that this was actually a group of people that maybe had some kind of trade with other areas, that there was some kind of activity more than just people trying to survive?
The swept up by the kelp and taken to a new island.
Yeah, I know.
It sounds like the Confederate woman who got impregnated by the Union soldier because a bullet passed very closely towards him before implanting itself in her. I just don't. I kind of like the boat's an easier. It's just an easier jump, and they have
a lot more sense. But I'm just wondering.
And to have the stone tools of a million years ago in Indonesia, that's fascinating stuff. So this is one of my favorite subjects because it seems like the more we learn about how we've explored this planet and the other life form. This is an amazing thing too. Other hominoids, other bipedal, standing up, tool using, crafty hominoids out there getting it done long before we did. So part of this too, though, another thing that's not mentioned in this, but this is another possibility, is, these tools are found. We're finding these tools also throughout deep into Asia and everything, these Neanderthal tools. So there is also the possibility that ancient man just adapted Neanderthal tools and took them places. This is one of those things that is also possible.
But you said, though, that this is 50,000 years prior to any other evidence of human boats, right?
Correct.
So this is the earliest evidence of that suggests waterfaring in any way.
Because
by 50,000 years.
Where the tools landed. Yeah.
So
that's quite a long time.
Yeah, that's interesting, but fascinating. All right, let's keep this show moving. We like the little asteroid sampler that could. That's right, the Hayabusa mission that went and sampled some rocks from Itokawa and returned to Earth and allowed us to get to know a little rubble pile that's floating through space. And yes, in calling Itokawa a rubble pile, I am being accurate.
It is. It's a big gravel pile in space.
It is. It's a compilation of a lot of dust and rock and lots of material that's probably is the result of the breaking up of a much larger asteroid object. So anyway, the size gives it a very small gravitational pull, and the Japanese with the Hayabusa mission used that to their advantage to be able to get into orbit around the asteroid and to get close enough to it to be able to actually grab some stuff from it. So a new paper in the Proceedings of the National Academies of Science. National Academy of Sciences has actually shown that the interstellar environment was a very, very rough place to be a little asteroid. The researchers concluded that the surface of the asteroid had been shaped by many, many impacts of a great variety of strengths. So some major events that probably shattered the asteroid and the original asteroid, broke it apart, maybe even caused some melting and of the heat of which probably caused melting of some of those fragments. So they found some bits of rock that appeared melted. Others fractured and melted the rock on smaller scales, turning solid chondrite into glass. Micrometeorites also have punctured the rock and melted small holes into it. So there are all these different clues that they're getting from actually looking at the rubble samples that they brought back. And so the grains show the effect of shock heating. So there's a change in state from crystalline to glassy. Additionally, there's signs of compression where there had been pressure from an impact actually squeezing the rock in the asteroid.
Wow.
And
Itokawa has been through some serious space bleep.
Yes, absolutely. And the surface, this isn't from this particular experiment, but the surface of Itokawa is very similar to chondrite meteorites. So it definitely is from it's a common form of meteorite, a common formation of asteroid that we were looking at. Itokawa is probably fairly representative of what's out there and the environment that has been out there historically. It's not a nice place. Kind of dangerous. It's nice to have an atmosphere like the one that Earth allows us. It's kind of nice.
Yeah.
What else do you have?
Speaking of good atmospheres, we put a man on the moon, but can we make medical marijuana more memory friendly? This is the quest of scientists who have recently pinpointed a region in the brain where marijuana causes forgetfulness. Area of the brain which is actively, being engaged in by the marijuana, THC compounds, whatever's in there, to actually cause the sort of working memory to suffer. And most importantly, it found it to be completely unrelated to its medicinal effects. So the medicinal effect areas are taking place in the neurons. I'll get to it here in a sec. The finding drawn from the experiment with happy, though unmotivated lab mice, if found to apply to humans, could lead to future medical marijuana that doesn't impede a patient's working memory while still treating his or her pain. A working memory is the ability to hold more than one thought in your head for a period of time, which might mean that I'm always under the influence, but I don't partake in that, but it's still, maybe it lingers. I don't know. So wouldn't that be horrible if you go to the doctor's like, well, I know there's no drugs in your system, but the only medical description I have for this, sir, is you are stoned. Yes.
All the time, naturally.
All the time? Oh, no. We have found that the starting point for this phenomenon, the effect of marijuana working on memory, is the astroglial cells. Astroglial cells. Says study researcher Giovanni Marzicano, French biomedical researcher institution INSERM, which he said in a statement there. Researchers found that a disruption of working memory comes not from the drug's effects directly on the brain's neurons, but a different type of cells, the brain's helper cells called the astroglia, which are also astrocytes, neuroglia. I mean, it's not glia. Yeah. Glia?
Glia. 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 Mm-hmm.
Yeah. So the glia cells, right? The researchers studied how the mice reacted to marijuana's active component and several similar synthetic chemicals. They were looking specifically at the receptors on the brain cells that react to those chemicals called cannabinoids, which are the compounds similar to active components in marijuana, the THC. So they had some genetically engineered mice. Some of these had with the reception on certain cells. One set of the mice had no cannabinoid receptors in the brain. One set had receptors only on neurons, and one set had them on the glia. And basically, they put them through the maze, got the mice stoned, put them through the maze. The ones who had it only the receptors on the neurons could go through the maze, get the THC, and find their way back to that maze next time out, no problem. And it turned out the mice with the receptors on the glia were the ones who were heavily affected. So basically what it means is in the future, we could have a scientifically engineered marijuana that allows you to remember where you put your paraphernalia. Right?
Oh, that would be That would be a boon to so many people. Yeah.
I bet the college dropout rates. Like I bet college. Just watch how quickly. Like if they actually did that and put that out and get it out into the general public. Watch. I wonder how heavily that one thing would impact grades at the college level. Maybe even that. You know, don't speculate in the high school level, but certainly in the college level. So like this might be like a very important educational platform.
Yeah. No, the really interesting thing about this study though is the fact that it's not acting on or through the neurons. And to date, there's not much evidence that that really ties cells like the astroglia to things like learning and memory. I mean, we know that they're the helper cells. And for years, it was just thought that they were like these packing cells in the brain that just kind of took up space and didn't really do much. And then it slowly we're accumulating evidence about the role that these cells play in the metabolism of the brain, in the speed of information processing, that they might actually assist in information processing in some ways. And this is a piece of evidence that goes in that direction, so that the THC is interfering with the astroglia, and that's interfering with the memory formation. So this is a really, really neat result from a purely neuroscience, understanding how the brain and learning and memory works. This is a really, really, really great finding. But, for people who like to smoke weed, you won't remember it tomorrow.
It might not be in your head later.
It might not be in your head later.
It might later.
Yeah. I want to get to one quick thing before we go to the break. This is This Week in World Robot Domination. We're soon to be dominated by pop-up robots.
Pop-up robots.
Pop-up robots. That's right. These researchers at Harvard, engineers, have created this fabrication process that basically relies on layering of carbon fiber and plastic, titanium, brass, ceramic, all these the different structures that would go into creating these microelectronic machines, these little robots. They're creating little tiny robotic bees. And the robotic bees, it takes less than a second for them to pop up and to be fully formed and ready to go. And the way that and they work almost immediately. You just put an electrical current through them so that it gets their little motors and gets the wings going. And the wings fly at over 30 hertz. This is really quick speed, amazingly fast, beautiful little robots. But the cool thing about this process that they're developing, it's based on manufacturing techniques that are currently available, using materials that are available and inexpensive. And so they say it allows us to use any material, including polymers, metals, ceramics, and composites. The ability to incorporate any type and number of material layers along with integrated electronics means that we can generate full systems in any three-dimensional shape. We've also demonstrated we can create self-assembling devices by including pre-stressed materials. And so the implications for this are just awesome. So if you have a CAD program to be able to, and it's all based on kids' pop-up book techniques. So pop-up books lead to pop-up robots. 3D.
This means in the future?
3D self-assembling robots. Pop-up robots.
In the future, we will have no place to hide. Like the internet becomes sentient, the robot AI is taking over the world, and we're huddled in a cave, and we will open the tome of ancient knowledge by opening this book, and then all of a sudden there'll be a pop-up robot. They'll just like, Rah!
That's exactly how it'll go.
The last humans will die by opening a book with a pop-up robot.
my goodness.
So I know we're out of time, but really quick, I want to talk about the ancient Ohioans.
Yes.
It's like they found this is a great story, that they found one of those old giant sloths. You know, the ones that were like thousands of, like when they stood up, they were as tall as 2 elephants. Huge ancient giant sloths that used to roam the North American plains. They found one that has 41 incisions that appear on the animal's left femur, right? And this is consistent with marks that would be used by stone tools, that would be removing areas of tendon connections, that sort of thing, to remove a hide and meat. And that so it's looks very specific to a hunting sort of what do you call it when you clean a carcass? Rendering the sloth, right, of its goods. This carbon dates between 13,435, 13,738. So, 13,500-ish years ago. That's first of all, I think this is the only case where it's been assumed for a long time that the giant sloth may have, and this one specifically, a Jefferson's ground sloth, I guess is what this is being called, is the first time Megalonyx has been known to have been killed or culled by humans. It's been supposed over the years that this is maybe how they went extinct, was the addition of modern man to the North American continent. This is the first evidence they've actually had of one, though. So it's pretty fascinating. It does make that connection. Like, we've sort of been looking for that connection between man and mammoth. Like, man killed the mammoth or hunted the mammoth into extinction. This is the first piece of evidence that is saying that perhaps the giant sloth of North America was actually perhaps hunted into existence by the modern man. But it's also pretty striking. Ancient Ohioans, 13,500 years ago. Now we have to find the people who did the killing. Yeah.
Well,
what's funny though, this is going to be very difficult to do that because this discovery of these bones were first discovered, I think, 1915. This is another one of those great discoveries that happens in a box in the dusty basement of a museum, right? This has been in some museum in Illinois for many years. So they don't know the exact location. They know it was found in a swamp near let's see, what was it? Some swamp in Ohio, right?
Mm-hmm.
So they know a general area. Like nowadays, they've gotten so advanced. When they make a new discovery, one of the first things you do is punch in that exact location into a GPS, global information system, locates where that find happened on the map. To anybody else going back trying to figure out where this was or to do more research in the area knows the exact general patch of ground that the discovery was made on. This was discovered in 1915, wasn't that accurate in terms of where exactly it was found. So that's a big mystery. So they would love to go back and search the exact area again, but they might not be able to.
On that note, it's time for us to take a break. We have a guest coming up. Yeah, we have a guest coming up in the second half. Carl Zimmer, science writer extraordinaire and a planet of viruses. That does it for this first half. Keep listening. We'll be back in just a few. would like to thank Audible.com for sponsoring this hour of This Week in Science. Audible.com is the leading provider of audiobooks with over 75,000 different titles in their library in a variety of genres. And Twis has found so many science-based books in their library throughout the years. And we know that you can too. So here's the deal. You can sign up for a free audiobook download, start your trial with them. All you have to do is sign up at audiblepodcast.com/twits. That's right. You get a free audiobook download of your choice. Could be science, could be something else, for signing up just to try out their products. So audiblepodcast.com/twits and get your free audiobook right now. Also, read along with the Twis Book Club. This last month, February, we read Carl Zimmer's A Planet of Viruses, which is available through Amazon or at a bookstore near you. This month, we're reading Dirt. That's right. We're reading a book about dirt. Want to know why dirt's important? What's happening to dirt? What farming is doing to dirt? That's what we're reading this month. Dirt. It's the book for March. Twis also has merchandise you might enjoy. Head over to twis.org to purchase our 2010 Science Music Compilation CD. We have a few still on the shelves, so get it before they're gone. There are limited supplies. That's right, 2010. I did say 2010, so this is a collector's edition, collector's item. 2010 limited edition Science Compilation CD. Also, we have World Robot Domination t-shirts. They're green with a nice picture on the front. World Robot Domination from Twis. Finally, Twis is supported by listeners like you. Your donations allow us to do all sorts of things for the show. They pay for our hosting, bandwidth, contractors we need to hire, fun things we try to do. And we appreciate any amount that you're able to give. Give $2. Give $2 a month. You can sign up for a monthly donation. You can give $2,000. Whatever you want to give, we will accept it. And we thank you very much. You make this show possible. We accept the donations through PayPal. Currently, there are buttons on each episode page on our website, twis.org. So head on over to twis.org. Check out the most recent episode if you haven't already. Maybe make some comments on the website about the show, about the science that you've heard. Talk to other people in the community and click on that donation button. Donate now. We thank you for your support. We really couldn't do it without you.
Answers lie somewhere within this scatter plot. Our first assumptions were correct. Disprove the rest. It's hard. The methods of hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't see.
I got my graph paper here. My graph paper, because this is This Week in Science. And at This Week in Science, we like graph paper. It's time for an interview. We have a guest on the show today, Carl Zimmer. He is a science writer, has written for many years for the New York Times, has a blog called The Loom. He has also written several books, Parasite Rex, and a book that we read for the Twis Book Club, A Planet of Viruses. Without further ado, if he's on the line, Carl, are you there?
I'm here. How's it going?
Yay! It's so great to talk
Welcome
to
to
you.
This Week in Science.
Hey, thanks.
Sorry to be keeping you up late. I know it's rather late over there on the eastern coast, the seaboard.
Oh, that's all right. I'm a bit of a night owl, so it's no problem.
Excellent. Maybe you'll get some good writing done while keeping you up. So, A Planet of Viruses. This book is a little bit different from other books that you've written. It's 100 pages. It's just kind of short and sweet, and the chapters are really concise. So, what spurred this particular book?
So I was invited to get involved in an education project that was being funded by the NIH about viruses. Basically, finding new ways to introduce people, including like high school kids, to this part of biology. People, they kind of vaguely know about viruses. They're kind of scared of them, but they don't really know even what the basics of them are. So we started talking about, how I could be involved. And basically what I started doing was I just started writing essays about different viruses. So one day I would sit down and say, okay, I'm going to write an essay about smallpox. And then another day, an essay about influenza. And then we basically ended up with 12 essays on 12 viruses. And, in each one, I was trying to touch on something that was important uh, about viruses in general. Where do viruses come from? I mean, how is it that 100 years ago there was no HIV, and now HIV is one of the major killers in the world? What happened? How did that occur? And so, with each essay, I would hit on a different important thing about viruses in general, and then we just realized we had a book.
That's really neat. And so, how has the response been generally to this book compared to your other books?
It's been interesting. I people sometimes post on Twitter, and there was one man who was talking about how he was reading it to his 12-year-old daughter, and I hadn't really thought of it as bedtime reading, but it's cool. And apparently she was wondering if the book was covered in rhinoviruses, which means that I must be doing my job right, getting these kinds of questions into the minds of our youth,
Absolutely.
Where are the viruses? Yeah.
And much less frightening, truly, than the original Brothers Grimm tales.
Less frightening? I don't know.
Those were terrifying. They had axe-wielding maniacs running around chasing children. It was truly.
Some of the stories that you told, Carl.
You could get away from the axe-wielding maniac. I don't think you could get away from a bad case of Ebola.
Exactly.
True.
And different from bacteria. I mean, recently there was a discovery of some bacteria species that has a spike that it uses to stab other stab cells and gain entry to cells and suck out their insides. Are viruses that crafty? Are they really finding ways, like stabbing host cells to be able to get into them and to be able to hijack the cells that they take over?
Yeah, so that was a really interesting study you're talking about, where these bacteria have these spikes they use. And I was communicating with one of the scientists, and it appears that the bacteria stole some of the genes for that spike from viruses, because viruses use a spike to get themselves into a host. Some viruses do. So they'll spike their way in and just inject genes in there like a syringe, and it's pretty nasty. Viruses are they're incredibly small, and they seem really simple because flu virus, for example, has only 10 genes. Doesn't seem like much, but that is enough to get into a cell to avoid the immune system pretty well. Flu virus actually has a protein that shuts down this incredibly complicated immune response inside the cell. It zeroes in on particular proteins and just shuts them down so that the cell is just completely helpless. So they're incredibly sophisticated, and it's all the more impressive because they're so small.
I feel completely helpless when I have the flu and I'm in bed. So they have a much larger scale effects from those very small, immobilizing one particular protein or one cell.
Yeah. Well, I mean, they are making, millions of copies inside of you. So they're small, but they're an army, definitely.
They're crafty.
They are, yeah. But a lot of why you're feeling bad is your own body mounting an immune response. That's part of what's making you feel lousy. Yeah, unfortunately, there's not a whole lot you can do. I mean, there's some antivirals you can take that are kind of okay, but somewhat effective. But, viruses, a lot of viruses really just kind of laugh at everything we throw at them.
As you've gone through the different viruses and you've been focusing on these, or you focused on these different essays, different groups of viruses, different traits that viruses have, is there anything that really stands out to you about viruses as a whole?
Just that there's so many of them.
Yeah.
I mean, we're so focused, and we've been traditionally focused on the viruses that make us sick, the cold viruses, the flu viruses, and they're important, but we have kind of ignored all the viruses that infect everything else on Earth. Everything gets viruses. There are even some viruses that infect other viruses. There are so many viruses now that scientists now realize that it's really hard to convey it. I mean, the words kind of fail you. The last estimate I had seen was that there's 10 to the 31st viruses. So a 1 with 31 zeros after that. And that's like 1,000,000 times more viruses on Earth than stars in the universe. It's crazy.
Wow.
It's not more than this. It's not more than the stars in the universe, but it does make it the predominant life form on Earth. Even though we hesitate to use the word life form with a virus yet, I mean, it does make it sort of like
except
we've. I mean, that doesn't make it
alien.
We are sort of parasitic in existence then to the virus just by the sheer numbers.
Well, they need us as hosts, and all the bacteria and plants and other life forms on Earth that they make their hosts. It's true. But, they have a relationship with us that's complicated. They've actually given us humans a lot of DNA. I mean, we've sort of accumulated virus DNA in the human genome, and we carry it along with us. There are viruses everywhere, and they could potentially be influencing the climate. They could be influencing the cycle of carbon and other nutrients across the whole planet. So you have to think about viruses as a planetary force.
Do you think that's a new perspective on viruses, just as scientists have become aware of them? I mean, I don't think I've ever heard them referred to as a planetary force. I mean, you normally just think of them as the things that give you a cold or the flu or that make you sick.
Yeah, well, there was just a sort of a bias. There was just a feeling that viruses couldn't be that important, and viruses are not that easy to observe in the wild.
Yeah.
You can see an elephant. There's an elephant. Okay, so there's definitely an elephant over there. But when you look at how many viruses do you see, you don't see that many, obviously. And actually, the scientists really thought that in the ocean, for example, they just didn't think there were that many viruses in the ocean at all. They didn't think that viruses could handle it. And it was just a bias. It turns out that like you scoop up a spoonful of seawater, there might be 1 billion viruses swimming around in it.
Which is just so hard to imagine. And you mentioned earlier the link between viruses and humans in our own genome, and that we've picked up viral DNA. We've seen studies through the years that that suggest links between viral DNA and human intelligence, human evolution of various traits. Is anything really that stands up to scrutiny there that you're aware of?
Well, there are. So here, the thing is that we know that there's a lot of virus DNA in our genome. The last estimates I've seen are that about 8% of the human genome is virus DNA. I mean, you can identify it as that, And that comes to about 100,000 different fragments of viral DNA in the human genome. And they got in there because they infected our ancestors, hundreds of thousands or millions or tens of millions of years ago. The virus infected, say, an egg or a sperm cell, and then the virus's DNA became combined with the host DNA and then got passed down to the next generations. And a lot of it could just be along for the ride, just useless stuff. It doesn't do anything. It doesn't help. It doesn't hurt us. It doesn't help us. But there do seem to be definitely some interesting cases. I think the best example is there's a protein that came from a virus that's essential for the placenta to work. So we're placental mammals, and our kind of placenta has to form a special kind of connection to the uterus to get the nutrients in.
Yeah.
And there's a protein that kind of clamps it together to make that connection. If you take that protein out, say if you do an experiment with mice where you genetically engineer them to take out this virus gene, the mice can't reproduce. So I think it's safe to say that none of us would be here if not for these viruses inside of us.
Right.
The stuff with the intelligence you mentioned, I mean, that's where you get more into speculation. It's not impossible. I mean, the fact is that there's some of these proteins that look like they come from viruses that are being produced in the brain.
Yeah.
So you've got these proteins floating around in there. They look like they came from viruses. Are they doing something in the brain for us, or are they just floating around and not doing much of anything? I mean, nobody can really say. It's tempting to say this is the secret to humanity, but I wouldn't go that far yet.
Not yet. Still got to wait for more evidence.
Yeah. In a year or two, I'll be saying it's all viruses all the way down.
Well, we've seen this too. There was a study we were talking about a couple weeks ago with a virus that was had an incredible sort of predator and prey escalation with a bacteria in the ocean, in which when there was a certain sensor on the bacterium when it was looking for phosphates in the ocean to feed upon, that when it started looking for them is when the virus would be aware that it was in a weakened state and then take advantage of it, and in incorporating would gain most of the nutrients because it itself had the ability to grab the phosphorus, I guess it was, for the microbe, but then would utilize it and more so for itself to grow itself. So they really are what our idea of what a virus is and infecting. It really does so, not just into the human immune system, but right down into the very DNA of a system and incorporating. And this is also the only creature that has been resurrected after many, many thousands and thousands of years. Viruses that they found in the ice cores have been brought back to life. This is perhaps the most industrious life form on planet Earth. And you're right, it's actually many, many more times than the number of stars. It's many magnitudes more than the number of stars in the known universe. So we are completely outnumbered. What can we do to better befriend the viruses and make sure that we are having a good relationship with them?
Well, I think one thing to do is to kind of get a better sense of how it is that we get sick from viruses. Like I mentioned HIV. HIV spilled over into our species. It started out as a chimpanzee virus. And then basically, if you look at the history of colonialism in Central Africa, you see us basically setting up the great opportunity for these viruses to find a new niche, because people were killing chimpanzees. They were getting infected. They might cut themselves and get this chimpanzee virus in their bloodstream. That alone wasn't enough to create HIV. What you needed was a big pool of potential human hosts who are in contact with each other. And that was happening more and more thanks to trains and timber operations and the growth of cities like what became Kinshasa. That's how HIV was able to take off. And we're looking at that. We're with the flu, with SARS, and there's going to be another big virus coming soon. So maybe if we can kind of get ahead, if we can figure out what are the candidates for the next big virus, then we can try to do a better job of preparing ourselves or kind of avoiding that spillover. That would be one way to be a bit more comfortable on this virus-dominated planet.
Yeah. But I guess that's got to be very difficult because, especially in the case of HIV, it existed in sort of symbiosis with the host. So even if we identify a virus out there that's in another organism or that's out there somewhere, we still have no idea what the effects will be if it transfers into humans.
Yeah, I mean, there's going to be a lot that's going to be pretty mysterious. I mean, I thought it was pretty remarkable that back in 2009, when there was this new pandemic flu that arrived, the swine flu 2009, we first became aware of it in Mexico. It was already in 23 countries by that point, by the time we were aware of it. Boom, all over the world. And scientists couldn't really say what was going to happen. I mean, we were lucky that it turned out to be a kind of virus that spreads fast, but is not especially deadly. So this was not a replay of 1918 where 50 million people died of the flu. But nobody was really sure. And that's a little scary.
Everything's going to be a pandemic. As you said, like the planes, the trains, everything. That was an example of a regular flu that wasn't any exceptionally virulent, didn't have a high mortality rate, but that you immediately, 24 countries immediately, because anything that we come across now is going to be a pandemic before we're even aware of it.
Well, it's theoretically possible that we could get ahead of them. I mean, if we had good monitoring systems set up around the world. I mean, if we had real public health that took advantage of 21st century, genomic technology. I mean, come on, we're seeing now technology coming out where you can sequence a whole human genome in less than a day for like $1,000 or $900. Yeah. So, I mean, if you can do that with a human genome, I mean, virus genomes are nothing. I mean, they're a tiny fraction of 1% of the size of the human genome. It should be so easy to be just scanning for these things and just having a sort of a virus monitoring system, like in the same way we monitor for wildfires or other kinds of disasters. We should be forecasting viruses, and we could do it if we were just so inclined. But instead, these things are just sort of surging around and they just pop up and we don't even know about it. I mean, everybody is so concerned right now, and I think rightly so, about another kind of flu that infects birds called H5N1. And, will that cross over and will that be really bad? And yet for all the headlines it's been getting recently, there's very little monitoring of it. Relatively few samples have been actually sequenced. There's not that much for what could be like the next big pandemic.
Can you tell us a little bit about the virus that creates jackalopes?
Oh, yeah.
What?
Yeah. You know about jackalopes?
I do not.
Okay, so if you're like out in Wyoming or Montana or something, you might go into a shop and see some postcards and they'll say, greetings from Wyoming or something, and there'll be a picture of a rabbit with little antler horns on it, and it's supposed to be a picture of a jackalope. I remember going into a diner. Hey, there you go.
Beautiful.
I actually went to a diner. I think, it was somewhere in Wyoming once a while back, where there was actually like a jackalope head mounted on the wall. I think specifically to make people from the East Coast look like idiots.
Right.
So there's this sort of legend of the jackalope, and I always just thought, again, it was just something to fool the people from the East Coast or the West Coast. But in any case, hey, there you go. Maybe that's
and there's pictures of it. We've got pictures of it for the just listening audience right now, and it is hilarious. It's a rabbit with antlers.
Now, what's really weird is that there's a little grain of truth to that story. There actually are.
Are you going?
Rabbits.
Do you hear him going, Silani?
Yeah, I'm gonna have to interrupt you right there. Can you say something again, Carl, real quick?
Hi, can you hear me?
Yeah, you're getting we're getting some weird feedback from you real quick. I'm gonna try calling you back.
Or can you unplug your headset and plug it back in again?
Or that.
Sure. I'll unplug and replug. How's that?
Oh,
Much
perfect.
better. It's the Cylon effect. Okay.
Sorry.
No problem. Sorry to interrupt
help
your,
with Kiki.
your
Good
tale.
job, Kirsten.
Okay.
The
So
Skype
you're about to tell me that there's some truth to the jackalope, which I just learned about. I'm already skeptical because it's a rabbit with antlers. How can there be a grain of truth behind the jackalope?
Well, because there's a virus. There's the papilloma virus. So the papilloma virus infects epithelial cells. So it can be skin. It can be mucous membranes. Any epithelial cell it can get into. That is not a real that is not the real jackalope. There's some really horrific pictures of rabbits infected with papillomaviruses, and
so it's kind of sad, actually.
Yeah, they seem to get it on their heads because they sort of they sort of bunk into each other and pass it that way. And in some cases it will grow. The virus actually causes the cells to grow faster than normal, and they create these strange looking growths that people, could charitably, there's one, could charitably think of as horns. So there's that one. It's growing out of kind of its mouth area. They also
this looks like a picture of a rabbit with tusks, and this is this is like a real photo of this virus in action on a rabbit.
Yep.
Wow.
Yeah. Now, every mammal can get papillomavirus, and it can cause these growths on rabbits, for example. It can cause very large warts on cows. Each species seems to have its own papillomaviruses. There's been a lot of coevolution of virus and mammal. There's another example of a real jackalope, as it were. With humans, I mean, we actually are all covered with papillomavirus. Your eyelashes are probably carrying it. As you slough off dead skin and that creates dust, there's a lot of papillomavirus in that. So you're walking through.
Yeah, it makes Eskimo kisses a lot less appealing. Or no, not Eskimo kisses, butterfly kisses with the eyelashes.
I'm going to go burn my loofah when we're done with this convo.
Exactly.
Yeah, again, you sort of have to reconcile yourself to being, coexisting with viruses. I mean, we have lots of viruses inside of us. We have papillomavirus all over us. Most of the time, these papillomaviruses are fine because all their way of growing is just to make the cells they're in grow faster, but not too fast. And then you just slough off the skin and grow new skin, and you're in this little balance with your viruses. And I mean, we all are. Now things get out of whack with some people. So there was a famous case, for example, I don't know if you can find a picture or if you'd want to show this picture, but there was a guy named Dede, D-E-D-E, in Indonesia, who had a problem with his immune system where he didn't have an immune system that was able to help keep infected cells in check, because the balance involves the immune system too. And so these infected cells would grow way too fast, because these viruses are incredibly sophisticated. I mean, you got to think about it. They are controlling the cell cycle, which is an incredibly complicated process. But this little virus can just speed it up in a very precise way. And so in the case of Day-Day, he would grow these enormous growths all over his body. And he ended up in a traveling freak show where he was known as the Tree Man. And it was just horrific. Now, that's a pretty unusual case, probably due to a mutation he had. The most common way that, or the best known way that papillomavirus causes, so there's Day-Day, and that's, prepare thyself. Ugh.
Mm-hmm.
So surgeons actually cut all that off of him.
Wow.
And
it does look like
bark.
look like bark. Yeah.
Yeah.
It's pretty
Yeah.
It looks like his
horrific.
hands and his feet are trying to become shoots or roots or something.
Right. You know,
Try and search for water.
Yeah, so just like the jackalope just seems too weird to believe, you know, the tree man seems too weird to believe, but again, it's this virus. It also causes cervical cancer. So
Right, HPV is what we know it as commonly.
Right. So HPV, and so and here's another case where it's getting into an epithelial cell, growing out of control and causing trouble. But again, it's only a rare, you know, it's a small fraction of people who carry HPV who develop this. It's particular strains that are particularly prone to cause cancers. The great thing is that what that means is that you could actually vaccinate against cancer. This is like a really important realization, and there are probably a lot of other cancers that are involved, that have viruses involved in one way or the other. So you know, the traditional strategy of just blasting cancer cells with chemotherapy, you know, it's worked okay. It hasn't been great, but here is a potentially really effective way to reduce the cancer burden with vaccination.
Yeah, I've been absolutely horrified by, well, at least the early primaries when this was being made an issue. Thankfully, those who were making a big issue out of whether or not we should be offering HPV vaccinations to young girls, most of those candidates have fallen off. Right. So we're not hearing about this anymore. But I was just so tremendously horrified by the fact that was being turned into a campaign issue. When we have the ability now to vaccinate against cervical cancer, at least the one cause that I know of that's predominantly been discovered to be connected to cervical cancer.
Yeah, I mean 15. Yeah, I mean the numbers I've seen are that 15% of all cancer is caused by viruses, and that's probably it's the real number is probably it's probably higher. So 15% are definitely caused by viruses. Think about that. I mean 15% you could possibly wipe out just with vaccines. That's we need to be getting on that.
I like that. Now. I'm like, good. Okay, good message. We're getting towards we're towards the end of the show, and A Planet of Viruses is it's a wonderful short read. I've had a lot of fun reading it. It's not dense. It's enjoyable. It's a good primer.
Not a textbook.
It's not a textbook. Yeah, it's a great read, and you'll learn great things like about jackalopes and cervical cancer and HIV and many other wonderful viruses on our planet, the planet of viruses. Yeah, and Carl also has another book out. I have a friend of mine gave it to me as a gift in hardcover, Science Inc., your science tattoo book, which when you were here in the fall, you said you were going and doing a book signing at and giving a talk at a tattoo parlor. How did the tattoo parlor book signings go?
Oh, they went great. I actually had all sorts of really interesting conversations with the people who run the tattoo parlors, because they know, they deal with a lot of scientists coming in. They've just gotten their PhD, and it's time to celebrate by getting a neurotransmitter molecule on their back.
Yeah.
So they've known about this phenomenon for a long time, and I've gotten really interested in the sort of the history and the anthropology of tattoos, because this scientist tribe with its markings is just the latest in a long string of groups that identify themselves with tattoos. Otzi the Iceman, the 5,300 years old, his body was found in the Alps, and he still had skin preserved on him. He had tattoos on him. The oldest.
I didn't know that.
That's true. Here's something really weird that I only discovered recently.
It was a neurotransmitter tattoo. That is really weird.
That would be very interesting. This is almost as interesting. Is that Brad Pitt has tattoos. He has one tattoo of Otzi, like an outline of his body, and then he has Otzi's own tattoos on other parts of his body. So it turns out that Brad Pitt is one of these Science Inc. freaks. Someone just pointed me to these images just recently. So
That's
go figure.
He's got Otzi copycat tattoos.
Yeah,
I like that. I didn't realize that. I did me an Otzi tattoo. Absolutely. That's pretty great. Do you have people coming up to you all the time being like, "Oh, you got to see this. Just let me pull up my."
Showing you inappropriate body parts to show you their science tattoo. I don't know.
Hey, no one's actually dropped their trousers, so we're okay. But there have been. I did give a talk at the New York Academy of Sciences, a pretty reputable place, and somebody felt the need to strip off his shirt to show a big DNA molecule on the back, but it was all right. He was just. We were among friends.
You're gonna be that guy forever that people have to show their tattoo to.
Hey, there's Brad Pitt. Yeah, that's the shape of Otzi's body. His left arm was sort of frozen, kind of pointing out that way because he was lying on his stomach. Yeah.
Oh, that's cool. I had no idea.
Yeah.
Carl, thank you so much for joining us today and talking about viruses and your books. And it's always great to get to talk with you. And I hope that this book does well, the Planet of Viruses book, that a lot of people are introduced to the idea of viruses through it, and that a lot of people start conversations to learn more about them.
Great. Well, thanks a lot. Thanks for having me. It's always a pleasure to be on the show.
You're welcome. Hopefully we'll get you back on again. Come on, write another book.
Okay. I'll get to it right now.
Put on a cup of coffee tonight. Hammer one out.
All right. Got my coffee. Gonna get to work.
All right.
Thanks, Carl.
Later.
It was great talking to you. Have a great night. Bye. That was Carl Zimmer. You can go to carlzimmer.com to find out more about him, his writing. His blog is The Loom. And the book we were talking about is A Planet of Viruses. Great educational, entertaining primer on viruses, and Science Inc. If you're into science tattoos, or as Carl said, the anthropology of this science tribe. I love that. It makes me want to go out and get a science marking. I don't think I
actually know some anthropologists who have anthropology oriented tattoos. So it's very close to home for them.
Yes. But anyway, we are at the end of our show. We are well over time. This is going to be a fun editing job for me. Since we're so far over, I'm just going to go for the Minion mailbag and we'll finish the show. Minion mailbag from William. Kirsten, Justin, I'm sadly getting far too good with issues of probability to let this one pass. So let me get this straight. You choose curtain 1 of 3 items residing behind them. It's then disclosed that the worst item is behind curtain 2. It is assumed that the placement of the items is random. I think Justin's analysis confuses prior and conditional probability. Please feel free to check and confirm my underlying assumptions. And so he's got a bunch of calculations that he comes up with that are actually spot on probability assumptions and calculations. Anyway, he goes on to say, let's see. He basically goes on to say at the very end, I'd hate to think Justin overturned a fundamental rule of elementary statistics, but who knows? I'm just a biology graduate student. What do I know? So in what you're looking at with the statistics, no, your stats in the beginning are not wrong. So you have 3 doors, 1/3 probability for each of them. 1 has a car, 2 have goats. So there's a 2/3 probability of getting goats. You make a choice, and it's a 1 out of 3 probability of getting the car. So the likelihood is that you made the wrong choice. But if you picked the car right, the host of the show is not going to, or if you picked the door wrong, if you picked a goat, the host of the show is then not going to go and open a car door. The host knows where everything is. So the host
They always show you a wrong door.
They're only going to show you a wrong door. And that's where the situation gets interesting. The probability and the calculation of everything relies on your first choice and the host's behavior, knowing that the host is going to show you the wrong door. And so because of this this behavior, it tilts the probability so that your chance of getting a car then is doubled from 1/3 to 2/3. And
if you switch, you have to switch.
If you switch, you have to switch. So the Monty Hall problem, you have to switch. You're not always going to get it. It's not a 100% likelihood that you will win the car, but
6 to infinity percent chances.
Yes, exactly. And so if you go online, there are a bunch of people that I went online and I looked. There are websites dedicated to the Monty Hall problem. There are YouTube videos that describe the problem over and over again. You can go through, they go through all the math. This is a very well covered topic. So I suggest if all of you out there go out and take a look, just Google Monty Hall problem.
And actually, I would even suggest, especially if you're in college, get some of those red cups that always seem to be littering college campuses across America. Get 3 cups and put one and a little object on it, and with a friend, run the experiment so that you move them around like the shell game.
And then
you know which one. They pick one, you show them a wrong one, you let them switch or don't switch. Do one set of experiments where you always switch, one set of experiments where you never switch. The numbers, regardless of what's on paper, whatever the math is, the proof will be in the experiment, and you'll have your answer.
Yeah. So it's Justin has not overturned a fundamental rule of elementary statistics here. It's just the way the problem works out, and
but don't think I wouldn't try.
You would. That's right. All right, everybody. That does it for today's show. On next week's show, we're gonna get back to the science, and I'd love to. Yeah, give a shout out to Ed Dyer, to Logan Waterman, Pamela Sue Taylor, Gordon McLeod, Jeremy Faulkner. Some great people out there, and all y'all in the chat room who've been typing along while we do the show. Thanks for watching, thanks for listening, and thanks for being a part of the community.
Yeah, thank you for listening. We hope you enjoyed the show. Twis is available as a podcast. Just Google This Week in Science in the iTunes directory, or if you have an Android device, you can look for Twis, the number 4 Droid app, Twis for Droid app in the Android marketplace. We're also listed under Twis, TWIS, in the iPhone directory.
And for more information on anything that you've heard here on today's show, the show notes are going to be available on our website, twis.org, with links out to stories that we've talked about. We also want to hear from you, so you can email us at kirsten@thisweekinscience.com or justin@thisweekinscience.com.
Be sure to put Twis, TWIS, somewhere in the subject line, or your email will be immediately spam filtered into oblivion. You can also contact us on Twitter, or follow us at Dr. Kiki or at JacksonFly. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, please let us know.
And we'll be back here next week, same time, same place. We hope that you will join us once again for more great sciencey goodness.
And if you've learned anything from today's show, remember,
it's all in your head.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news. That what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. 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 And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 Got a laundry list of items I want to address. From stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought. And I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say. And if you've learned anything from the words that we've said, then please just remember it's all in your head. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.